Okay, so in the second video for assignment number 5, we're still talking about the 6 trig functions, but we're just giving a little bit different information. So you can see for this example, we're going to evaluate the trig function determined by a point in quadrant 1. So in the last video, we were given the actual ratio. Now we're given a point, but it's still in quadrant 1. So it says let theta be an acute angle in standard position, which means that the first leg of the triangle is on the positive x-axis, whose terminal side, so the end side, has a 0.35. So I'll call this 0.35, which means it looks like this. So I have a right angle right here. Now, this fact that they give me the 0.35 means that to get there, I go over 3, up 5. So when they actually give me a point on the terminal side, they are, in fact, giving me the 2 side lengths of the triangle. You'll see now I have to find the 6 trig function instead of 5 because they haven't given me one. But other than that, the process is the same. This is still my theta, so I know the opposite and the adjacent. I just need to find the hypotenuse. So I'm once again going to use the Pythagorean theorem. 3 squared plus 5 squared is going to equal x squared. Take the square root of 35, and I get the square root of 34. Again, for this one, I left it as the square root of 34. If you wanted to, you could have converted it to a decimal. Now I go through and find the 6 trig functions. I always find sine, cosine, and tangent first, and then take the reciprocals. So sine of theta is opposite over hypotenuse. So I start with 5 over root 34. I don't like the root 34 in the denominator. When I multiply the top and bottom by it, I get 5 root 34 over 34. Again, if you give decimal answers, that is just fine as well. Then I find the cosine of theta, which is just the adjacent. So I get adjacent over hypotenuse, so it looks very similar, but instead of a 5, I have a 3. So 3 root 34 over 34. And tangent of theta is opposite over adjacent, so I don't have to deal with the radical at all. It's 5/3. Take my reciprocal functions from sine, I go to cosecant. And I flip the original so that I don't have to mess with the radical. The root 34 goes on top. Cosine goes with secant. I flip it again. I get root 34 over 3. And cotangent, I flip tangent. So I get 3/5. Again, if I'm given a point in quadrant 1, that's the process I go through. Very similar to what we did before. Having said that, sometimes I'm given a point, but it's not in quadrant 1. So on this next example, it's going to switch gears just a little bit because we're going to move out of quadrant 1. So now we're going to start looking at 6 trig ratios of a right triangle, not necessarily in quadrant 1. The good news is the idea doesn't change. We just have to deal with negative. So here we're given a point, -4, 7, on the terminal side of an angle. Find the 6 trig ratios. So we're going to plot the point and draw a triangle. Again, we're going to deal with the reference angle. So the angle from the x-axis is key. So -4 up 7 is over here. That's the point I'm talking about, so I connect it to the x-axis because I'm dealing with the reference angle. I'm always going to build an acute triangle, actually, from where it starts. So here's my right triangle. Now this is a -4, and this is a +7. So again, we're going to have to deal with positive and negatives when dealing with this. Your hypotenuse, though, will always be positive. So now that I have 2 sides of a right triangle, I'm going to label the sides accordingly. So I did that, and now find the missing side. That's using 7 squared plus -4 squared equals side x again, x squared, square root both sides. And in this case, I got x equals the square root of 65. Again, I'm keeping up with radicals. You can switch to decimals. And now I'm going to list all of the trig ratios, all 6. So I always start with sine of theta. Again, it's opposite over hypotenuse, so 7 over root 65, which means it's 7 root 65 over 65. Cosine of theta is adjacent, so -4 over root 65, so it's -4 root 65 over 65. And tangent of theta is going to equal opposite over adjacent, 7 over -4, or -7/4. My reciprocal functions, sine goes with cosecant. Cosecant of theta then is is 5 root 65 over 7. So I reciprocate the original. Secant goes with cosine, so it's negative root 65 over 4. And cotangent of theta is negative 4/7. So again, whether I put the negative on top or bottom doesn't matter. I can put decimals if I want. Decimals just make it a little harder to take the reciprocals in the end, but I would just do it from the original. So one more example. Given a point on the terminal side of an angle not in quadrant 1, evaluate the remaining 5 trig functions. So this time they actually drew the triangle for me. So I'm just going to work from there. I always connect it to the x-axis because it's that reference angle that I care about that we've talked about for a few days now. Reference angle is always from the x-axis. This is the point 3, negative 5. It means I go over 3, down 5. Once I have that, I would complete my triangle by finding the other side. 3 squared plus negative 5 squared is x squared. Both sides. I get x is the square root of 34. So square root 34, and now I find my trig functions. This is the opposite, adjacent, and hypotenuse. Sine of theta is opposite over hypotenuse, negative 5 over root 34, which turns into 4 over. Cosine of theta is going to be 3 over root 34, which is 3 34 over 34. Tangent of theta is opposite over adjacent, so negative 5 over 3. The reciprocal of sine is cosecant of theta, so that's negative root 34 over 5. Secant is the reciprocal of cosine, so it's negative root 34 over 3. And finally, cotangent of theta is the reciprocal of tangent, so it's negative 3/5. Again, I didn't talk about it on the last one, but these signs should make sense given the quadrant. We know that in this quadrant, cosine is positive, sine is negative, and tangent is negative. So that should match with these functions as well. And you'll see that sine and tangent are both negative, cosine is positive, and therefore the reciprocal signs would always match. All right, once again, I would encourage you to pause the video and try guided practice number 13. And once you've completed that, come back and check your answers. When I did number 13, I plotted the point from negative 3 to negative 4, so it landed in this quadrant, quadrant 3. Once I was there, I found my third side, my hypotenuse, by doing negative 4 squared plus negative 3 squared equals x squared, and square rooted all of that, and I got x equals the square root of 25, x equals 5, so we remember the special 3, 4, 5 right triangle. We need to use that. That makes this one nice and easy. So the sine of theta. Remember, my theta is my reference angle, so this is the opposite, this is the adjacent, this is the hypotenuse. So sine is opposite over hypotenuse, so negative 4/5. Cosine of theta is adjacent over hypotenuse, so negative 3/5. And tangent of theta is opposite over adjacent, so negative 4 over negative 3, which makes it positive 4/3, which makes sense since tangent is positive. My reciprocal functions, sine and cosecant, go together, so I get negative 5/4 for cosecant. Cosine goes with secant, so I get negative 5/3 for secant. And cotangent goes with tangent, so I get 3/4 for cotangent. Okay, so that's the end of that skill from this section. So I'm going to stop this video, and I will make a new one for the next concept. So this is video 2 that goes with assignment 5. Thanks.